All right, let's get right into it. Building a global application on AKS. It's so much more than just spinning up a few extra clusters, right? It's really about architecting for security and performance from the very edge all the way down to the core. So in this explainer, we're going to skip the 101 stuff and jump straight into designing a complete enterprise-grade solution for taking your applications global, securely.
And this is really the big question, isn't it? A single region setup, that's one thing. But when you go global, you're hit with a whole new set of challenges. How do you slash latency for users in, say, Tokyo versus London? How are you fending off attacks right at the edge? And how do you intelligently manage traffic across all these different deployments? The truth is, a simple regional architecture just won't cut it. You have to build for the globe from day one. So where do we start? Well, every great fortress needs a really formidable front gate. And in our global architecture, that front gate is Azure Front Door. This is the spot where every single user request from anywhere in the world is going to land first. Think of it as our global receptionist, security guard, and traffic director all rolled into one powerful service.
Now, the key phrase to lock onto here is the Microsoft Global Edge Network. Don't think of this as just one big load balancer somewhere. It's a distributed service that lives at hundreds of locations all around the world. What that means is a user in Tokyo connects to an edge node that's physically in Tokyo, while a user in London hits one in London. This guarantees the absolute lowest possible latency for that initial connection.
Okay, so what does Front Door actually do at that edge? Well, first off, it handles the global load balancing, which means it intelligently routes users to the healthiest and closest regional backend. And, crucially, it applies a web application firewall, a WAF. This thing screens for all the common junk like SQL injection or cross-site scripting before any of that malicious traffic even gets a sniff of your virtual network. It also handles SSL termination right there, which, trust me, simplifies certificate management like you wouldn't believe.
So our request has been vetted by Front Door, it's clean, and it's been routed to the correct Azure region. But its journey isn't over yet. Now we need a much more sophisticated regional traffic manager to guide it once it's inside our virtual network. And this is exactly where the Application Gateway Ingress Controller, or AGIC, comes into play.
AGIC is basically the magic that connects Azure's really powerful Layer 7 load balancer, the Application Gateway, directly to Kubernetes. What it does is it watches the ingress resources that you create in your AKS cluster, and then it automatically configures the Application Gateway to match what you've defined. It's the perfect translator between the Azure networking world and the native Kubernetes world.
Now, you're probably asking, wait, why do I need both? Why not just use Front Door? And this is such a great question because it highlights a critical design pattern, separation of concerns. Front Door handles the global routing between your regions. Application Gateway, on the other hand, handles the advanced regional routing into your virtual network. It can make much more fine-grained decisions, like sending requests for, say, API to one set of pods and images to another, all based on the same Kubernetes ingress objects your developers already know and love.
All right, so we've managed our traffic from the edge of the internet all the way into our VNet. Now let's talk about the final destination, the AKS cluster itself. For a truly hardened security posture, we absolutely do not want the brain of our cluster, the Kubernetes API server, exposed to the public internet. At all. You know, this right here is an absolute game changer for security. With a private cluster, the API server, the control plane for your entire Kubernetes environment, it doesn't even have a public IP address. It gets an IP from your own virtual network. It is completely, totally invisible and inaccessible from the public internet. Any interaction, whether it's a CI/CD pipeline trying to deploy or an admin running kubectl, must go through a secure private endpoint that's on your network.
And the benefits here are just massive. Instantly, you've eliminated a huge public attack surface. You're guaranteeing that sensitive cluster management traffic never ever traverses the public internet. And it forces you into a zero-trust mindset. You have to be on the private network to manage the cluster. Period. There is no other way in.
Okay, so we've looked at the three core components: our global gatekeeper, our regional traffic cop, and our secure fortress. Now let's really make this concrete. We're going to follow a single packet from a user's browser all the way to an application pod and see how these pieces work together in perfect harmony.
So let's trace the flow. A user's request first hits the nearest Azure Front Door global edge point. The WAF immediately scans it for threats. Assuming it's clean, Front Door routes it over Microsoft's high-speed backbone to the correct regional application gateway.
That gateway then takes over, forwarding the request to the right service inside the VNet, and it finally reaches an application pod running safely inside our secure, private AKS cluster. You see, each step provides another layer of security and routing, creating a flow that is secure, fast, and massively scalable.
Now that we understand the flow of data, let's step back and distill this down into a real architect's playbook. We'll look at the key design principles and, just as important, the critical trade-offs you're going to need to think about.
This table really visualizes that whole defense in depth idea, and I want you to notice the relationship between complexity and scope. Way out at the global edge, the WIF is a low-complexity, high-impact shield. It's super easy to set up and it blocks threats early. As we move deeper in, network security groups offer way more granular control for microsegmentation, but that comes with medium complexity. You have to manage all those rules. And finally, locking down the control plane with private link, that gives you the ultimate security, but it's rated high complexity for a reason. It fundamentally changes how your CI/CD pipelines and admins connect, often requiring things like jump boxes or VNet integration. As the architect, your job is to balance these layers, deciding just how much complexity you're willing to take on for each level of security.
So let's lock in your playbook. First, you absolutely have to use WAF at front door for global protection. I'd say that's non-negotiable. Second, isolate your AKS control plane with private endpoints. It truly is the gold standard for security. Third, use AGIC to bridge that gap between Azure networking and Kubernetes natively. And finally, and this is maybe the most important takeaway, always remember that this architecture intentionally prioritizes security and scalability over simplicity. And when you need an enterprise-grade solution, that is absolutely the right choice to make.
So we've done it. We've architected a secure and efficient front door for our global application. But here's the thing. Ingress is just one piece of a very large puzzle. Now that the perimeter is secure, the next bottleneck is going to reveal itself. Is it going to be database replication latency across continents? Maybe egress traffic control? Or building a single unified global observability platform? Well, that's the next architectural challenge to tackle. Happy architecting!